So the final technique on the advanced section would be the integration by partial fractions. So again, as what I have mentioned previously in our class, um, most likely you'll be able to understand this topic if you have a base knowledge on what partial fraction is. So most likely, the easiest way for you to do to be able to for you to be able to understand what partial fraction is it's a fraction. So of course, obviously it's fraction, di ba? I think the only difference here is that the degree in the numerator. So let's say the function of x to the power of n. Then there's another function of x in the denominator. So let's say it's to the power of m. So it's considered as a partial fraction where because the exponent in the denominator is greater than the numerator. So that is always the case for partial fraction. So meaning you cannot do long division on these types of fractions. So you have to do another method which is called partial fractions or partial fraction decomposition. So that's how you want it to understand this topic. So um, these are fractions which cannot be used by long division. So long divisions, on the other hand, can be used if the denominator has a lower degree than the numerator. So if this one is the case, so you have partial fraction. So the other way around, if it's greater than, so if m is lesser than n, so you use long division. Okay. So in most cases in partial fractions, we are only going to have to look for factors in the denominator for us to partially decompose that particular fraction. Okay, so we have four types. So there's a distinct linear factor, distinct linear factor. So probably when you're going to search these types of factors in your partial fractions, there will be four. But murag duha ra siya, but may mo siyang four because the two are just repeated. Okay, so we have distinct linear factor. That would be the one type of factor in the denominator. Then next is we have the repeated linear factor. Repeated linear factor. So that's the same as number one, but it's just repeated. So notice that it's repeated to the power of n. So number three is we have a quadratic equation. So distinct quadratic factor. That would be the third one. Then the fourth one would be a repeated quadratic factor. All right. So I think the next step would be for you to understand what will be the use of these factors in the denominator. So for example, you have discovered that you have a distinct linear factor. So the next step would be to apply the partial fraction decomposition na formula, or let's say the partial fraction decomposition term that you need to apply. So this would be the factor or the fraction that you need to use for distinct linear factor. For repeated linear factor, notice that it's the same as above, but you have to repeat it until you reach the certain degree of exponent in the denominator. So for example, this one is to the third power. So let's say if this one is cube, so meaning na pa na siya plus c, di ba? Plus c all over ax plus b to the power of 3. So it will depend on how long the repetition will be. Okay. One thing is that if you have, let's say, two factors in the denominator, let's say x plus 2, then the other one is x minus 2. So you're going to have two distinct linear factors, diba? Line is lang a factor, distinct linear factor, meaning it's unique with the other term. So distinct, so it's unique, it's different from the other term. It's not the same all throughout. So that's why it's distinct. So meaning if you have two distinct linear factors, so meaning you still have to add another distinct linear factor, but it's just ax plus b, depending on the distinct linear factor that you're going to have. So this to the power of n, diba? So compared with repeated linear factor, so for example, this one is x plus 2 squared. So this one is x plus 2, x plus 2 squared. Then this one is x plus 3, x plus 2 cubed. So the same ang factor, diba? Because it's repeating. So for distinct quadratic factor, it's the term that you need to use is ax plus b, and then all over ax squared plus bx plus c. And then for repeated, it's the same case for repeated linear factor. So you have to repeat the third line. So you have to repeat it again up until you reach a certain degree of exponent that is given to you. So I think that's why I found it difficult for you guys to absorb this one, okay? Especially if you don't have the partial fraction topic in your senior high, because once you deal with quadratic factors, especially with repeated quadratic factors, you'll be able to reach 5 unknowns in your equations, and usually we solve those types of um, equations using matrix. So, so probably sa inyong case, if wala mo ana sa inyong senior high kanang matrix, kanang solving 5 unknowns, 6 unknowns, so on and so forth. So probably I think the best thing that you can do is to solve 3 unknowns siguro at best, diba? Using 3 equations. But for 4, 5, 6 unknowns, so that would be really difficult to use using elimination and substitution, diba? So kailangan siya special technique which is called matrix. So anyway, probably what will come out in the exam is just probably repeated linear siguro, or repeated quadratic, and it will depend. Okay, so let's try to solve 4. So 4 lang para di mo makuratan. Okay, so notice that the given problems presented to you follows the condition that I am giving earlier. So the numerator has a smaller degree than the denominator. So first degree, then the denominator is second degree. So this one is cube. This one is to the power of 4, diba? 1 plus 3. If you try to expand this one, it's x to the power of 4, diba? This one is squared, this one is cube. Cube, and then this one is 4. Then fifth power, diba? So it's always greater than the the denominator is always greater than the numerator in terms of degree, or the highest exponent being expressed in the function. All right, so let's try to understand first number 1. So the first thing that you need to do is you have to solve this using partial fraction first before you're going to integrate. So meaning the integration comes later. What you need to do is you have to use partial fractions first. Then after simplifying using partial fractions, that's the time that you're going to integrate your equation. So the purpose of partial fractions is to decompose the existing equation into a much simpler version, which is in partial fraction, which is in fraction form gyapon, di ba? So para mag-add og kuan good. So for example, you add 1 over x plus 1 over 2x, then iniga-add mo mura siya complicated na, di ba? So we try to bring back the equation back to its individual terms, di ba? Kanang itong yung mga addends. So, mo to atong i-try o achieve sa kaning akuan. So, again, if you try to look at the denominator, so you may say that it's quadratic, di ba? And then you might say that you um, want to use distinct quadratic factor directly. But that's not the case always if it's squared. So what you need to do is you try to factor out the existing equation first, if it's factorable. So for example, this one in terms of factor, so this can be expressed as x plus 3, x plus 2, di ba? So given that, so you have here, let's, so, so instead of the given one above, you may try to rewrite it as 2x plus 11, and then you're going to have it as x plus 3, and then x plus 2. Okay? So for the time being, try to ignore lang the integral symbol. So we try to solve it using partial fractions first. So again, upon observation, you're going to have two distinct linear factor. So it's linear because it's to the power of 1, diba? That's the purpose. It's called why it's called linear. So distinct linear factor. So factor meaning it's being multiplied with another term. So that's why it's a factor, di ba? Kung na siya itong tawag sa multiplication, di ba? The parts of the or the items being multiplied, those are factors. So as per rule, so again we need to try to decompose the fractions into its partial components. So again, the formula is this one, a over ax plus b. So meaning you have to follow what is the given distinct factor is. So that would be a all over x plus 3. Then again, since we have another type of distinct factor, that would be plus b all over x plus 2. Okay? So meaning you have two different sets of unknowns. So that would be the a variable, that would be the b variable. So how are you going to find a and b? So let's multiply first the whole equation by the denominator of the left side. So multiply by the denominator x plus 3, so x plus 3, then x plus 2. So this would give us just 2x plus 11 is equal to a times x plus 2 plus b times x plus 3. Now you're going to solve your unknowns a and b. So we have two methods in solving your unknowns. That would be one, elimination. So let me try elimination first. Elimination. The second one would be equating coefficients. So marag medyo labad siya kay Isa kasi dyan may nagtuon ani. So elimination means you have to look at the different, so you have to utilize this equation now and try to imagine or look for the values of x that can eliminate one variable and um, retain the other variable. So most likely this method is only applicable if you have 2 to 3 unknowns, diba? So equating coefficients, the advantage of this one is you have to it's applicable with more than 3. So it may be also applied with 2 to 3, but mara, uh, it it will depend on your kwan siguro, on how you're going to use these methods. So for example, I'm going to utilize again the kanin siyang formula dire. So if I want to retain A, so I want to have my value of x as -3. So at x equals -3, ba? So I'm going to have 2 times -3 plus 11 is equal to A times -3 plus 2 plus B, then -3 plus 3. So notice that this becomes 0, di ba? And then 0 times B is just 0. So meaning we don't have any more B variable. We only have the A variable now. So next is would be -6 plus 11 is equal to A times -1. Then that would be 5 equals -A. So meaning our A would be equal to -5. So we now have a first value for our unknowns. So of course, to look for the other variable, you just have to set again another value of x to eliminate A. So that's why it's called elimination, di ba? Setting a value for x to eliminate the other variable. Eliminate the other variable, retain one variable. So let's say at x, so to eliminate A, our x should be -2, di ba? So 2 times -2 plus 11. So again, take note that probably in your midterm exam, you're not allowed to use your calculator. So you have to do some mental math or manual math in the process. So b times -2 and then plus 3. So again, notice that this one becomes 0. 0 times a is just 0. So this one is -4 plus 11. Then you're going to have b times 1. So this means that b is equal to 7. Okay, so this one is the method of elimination. So on the other hand, if you're going to, in contrast to the elimination method, we have the equating coefficients. So I think the hassle of equating coefficients would be to expand the equation. So that's why it's more it's more complex, but it's really an effective method of equating, getting the unknown variables. Kay para mag-set up yung equation with 2 unknowns and 2 equations. So mara jud kaya ka na pina-algebra sa una ninyo nga solving 2 equations with 2 unknowns na, di ba? So what we need to do in equating coefficients is we need to expand this equation. What do you mean by expand? This means that I have to expand the right side of the equation. So 2x plus 11, then I have to multiply a inside the x plus 2. So this becomes ax plus 2a, and then plus b, bx plus 3b. The next step is I'm going to group together the terms in x on the right side and all the constants. So this would be a sub x plus b sub x, and then 2a plus 3b. Sorry. So 2a plus 3b. Okay. So since it's called equating coefficients, so let's try to take out the x first. So you now have a plus b times x, diba? So marag mahimo siyang coefficient sa x. And then of course the constant, since it's already a constant, so we don't have any coefficients for constant because it's a constant. So next key thing here is, since again equating coefficients, so we need to look out for the coefficients in your equation. So coefficient of 2 is this one. I mean rather coefficient of x is 2. Then we have a constant of 11. So on the right side, the coefficient of x is a plus b. Then the constant is 2a plus 3b. Okay, so by equating coefficients, 2 against a plus b. 2 equating coefficients, coefficient of x. Para yun maglibog, so you may also write it in this manner. So I'm going to write the coefficient of x, so semicolon, that would be 2 equals a plus b. So pwede po siya na sad. And then the constant would be 11 is equal to 2a plus 3b. Siya, di ba? So you have two equations with two unknowns, and I think you can solve this one using your knowledge in your algebra in your high school or senior high, solving two equations with two unknowns, diba? Through elimination, through substitution, so on and so forth. So wala siyang kuan sa equating coefficients. So for example, we're going to try to eliminate let's say b first, so multiply by negative 3. So negative 6 plus 11, that would be 5. Then this would be negative a, diba? So a is negative 5. And then b is, so negative 5, that would be 7. So coming from equation 1, 2 equals negative 5 plus b. Alright? So muna siyang the process of partial fraction. So meaning, this will be our new answer na kani siya. Muna siya ang among end product sa partial fraction decomposition. So, if we want to try to integrate now, so integral, so instead in writing the original term, so we have to write now negative 5, that would be the a, di ba? X plus 3, x plus 3, and then plus b, which is equal to 7. 7 over x plus 2. So let's make it a bracket lang siguro. So muna siya ang inyong new nga equation coming from partial fraction decomposition. So in most cases, our answer that you'll be expecting in partial fractions are all in ln or in logarithm. So if you try to decompose this one further, you're going to have negative um, we're going to have negative 5 and then dx all over x plus 3, then plus 7 dx over x plus 2. So again, notice that it's really in terms of ln, di ba? But if you want to verify for yourself why it's ln, so you may also do this method, murag manual mo, di ba? So x plus 3, then du is equal to dx. Na, di ba? This one is u is equal to x plus 2. Getting the derivative, it's still dx. So both terms will give you integral of du over u. So again, most of the answers in partial fractions are all in logarithm, natural logarithm ln. Okay, so final answer would be negative 5 um, ln of x plus 3, then plus 7 ln of x plus 2 plus c. So if you notice, mas dali ang pag-integrate compared with the partial fraction aspect. Okay, so let's try to review again our process. Again, we have to be careful if the denominator can be factored out first or not. The next one is apply the formula. Then the third one is we try to eliminate the denominators, diba? So that's why you multiply it with the denominator, then having this answer. So fourth one, it could either be, so fourth step, so either you use elimination or equating coefficients, depending on your style. So again, step 3 multiplied by the denominator would give us this answer. Okay, and then after the process of finding the unknown, so the fifth step would be, of course, to integrate. Okay, so questions for the first example.
Wala naman, sir.
Okay, so no questions for example number 1. So let's try to proceed to a more complicated um, example. So next is we have here the integral of x cubed minus 1 and then x times x plus 1 cube dx. So again, if you try to look at the given equation, the degree is rather the degree in the numerator is lesser compared with the degree in the denominator. So what you have to do here is you try to again simplify the terms that you are presented with. Okay. So for the numerator, this one is difference of cube, diba? So this can also be simplified. So again, try to simplify the given expression as much as you can. So this one is multiplied by binomial and then quadratic, diba? Then this one is you have one distinct linear factor, x. The other one is repeating linear factor, x plus 1 cube. So for numerator, so um, that's the difference of cube, diba? Difference of cube. So what will be the formula for that one? So if you try to remember your algebra, it's a minus b, then a squared plus 2ab. I think it's 2ab. It's ab, rather, it's ab. Okay, so looking at the simplification process of the difference of cube. So of course this one is cube because one cube is still one, diba? So looking at the expression, so a minus b cannot be simplified with um, or there's no term that can be eliminated in the denominator as well because it's a minus b. Then and then the term in the denominator is x plus 1. So we have to proceed as the given or the original equation. So again, try to ignore first the integral symbol by just writing the fraction because we're going to solve it using partial fractions first. So we're going to have x cubed minus 1 all over x times x plus 1 cube. Okay, so next is you're going to have a over x. That would be the first distinct linear factor. Next is the repeating linear factor. So a over x plus 1 plus c all over x plus 1 squared plus d all over x plus 1 cube. So as you can see, you're going to have to solve for 4 unknown variables. And again, that's where the the difference in techniques will come in. So probably if you are good at elimination using 4 variables, so you may do that one. But if you want your answer to be sure, so you may use equating coefficients. So multiply everything by the denominator. This would give us x times x plus 3 cubed. So the equation becomes x cubed minus 1, then a times x plus 1 cubed plus b x plus 1 squared times x. So there's still an x variable plus c. This becomes x plus 1 times x, and then d just times x only. So looking at the equation, if we're going to use elimination, let's say at x equals -1. So you're going to have to eliminate three variables directly, diba? And we don't want to do that because we want, so pili siguro you may do that one, but you only have d as your variable. Mura yung masolve. But for the other elements, I think you cannot solve anymore the other two. So the best way for this one is you use equating coefficients. Equating coefficients. And that would be a hassle, di ba? So equating coefficients. So again, trying to expand the equation. So x cubed minus 1. So let's try to expand the x plus 1 cube first. This would give us x cubed pa. So murag diyan na ang dilemma sa inyong pagkuhan, di ba? Okay, so again, if you are having difficulty expanding this one, so try to remember Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So this is the cube part. A plus B cube. And this will reflect as A cube plus 3A squared B plus 3AB squared plus B cube. So that's how you're going to use Pascal's triangle. So utilize Pascal's triangle. So x cubed plus 3x squared. So times 1 is just 1 plus 3x plus 1. That's the first one. Second one is we're going to have b times x squared plus 2x plus 1 and then multiplied by x again. C is just c times x squared plus x and then d is just dx. Okay, so I'm trying to expand further. So ax cubed plus 3ax squared plus 3ax plus a. The next is bx cubed. So I included cube because ako siyang i-multiply with another x. And then plus 2bx squared. Then plus bx. Then plus cx squared plus cx plus dx. So again, grouping together the similar terms. So this would be, so the cube one first. So a cube. So para di mo magsig kadugay sa inyong kuan, so try to eliminate the, using this one, a cube. So a, and then plus another cube here, b, di ba? And there's no any more other cube variables. So this is x cubed. So one way to do it quickly, by grouping it together na lang. So next is the x squared na variable. So x squared, you have 3a x squared, so this one is 3a. So where's another x squared in the equation? So here, 2bx squared, so plus 2b. So another x squared will be coming from c. So this one is plus c, then multiplied by x squared. So next term is the x variable, so 3ax. This one is coming from b, then c, and then d, multiplied by x. So what's left is just the constant, which is a. So again, equating coefficients. So if you're going to look at the equation on the left side, you only have x cubed and then minus 1. Diba? So we only have the coefficient for x cubed and 1. So how about for x squared? How about for x squared and x? So of course, since it's not found in the left side, meaning it's 0, diba? Because if you try to expand this one, this would be x cubed minus 0x squared minus 0x minus 1. So this will be the coefficient of your x squared and x parameter. It's equal to 0. Okay, so let's try to write it in green lang. So again, equating coefficients now. So starting off with x cubed, x squared, x variable, and then the constant. So we have 4 unknowns. So again, the number of equations will translate into the number of unknowns that you're going to have. So meaning if you have 3 unknowns, you're going to have 3 equations. If you have four unknowns, meaning you have to get 4 equations as well. Okay, so this is 1 equals a plus b. The second one would be 0 is equal to 3a plus 2b plus c. The third one would be 0 equals 3a plus b plus c plus d. And then the last one would be negative 1 is equal to a. So you have 4 equations. 1, 2, 3, and then 4. So notice that the first one is already solved, which is negative 1 is equal to a. So a is equal to negative 1. So na natin answer, di ba? So next step is um, using equation 1. So 1 equals negative 1 plus b. So b is equal to 2. So next is using equation 2. So 0 equals 3 times negative 1 and then plus 2b. So 2 times 2 plus c. So c is equal to, so negative 3 plus 4, so it gives negative 1. Then lastly is d. So using equation 3, so you're going to have 0 equals 3 times negative 1 plus 2 plus negative 1 plus d. So negative 3, negative 4, then so d is equal to 2. So there lang, d is equal to So that's how long the partial fraction is. So partial fraction pala na siya. So next is we now apply our decomposed fraction or our partial fractions. So we now have the integral of so starting off with the first one, so that would be -1 all over x, then plus 2 all over x plus 1, and then -1 all over x plus 1 squared, and then plus 2 all over x plus 1 cubed, and then dx. So separately, you're going to have it as negative dx over x plus 2 integral of dx all over x plus 1, and then minus integral of dx all over x plus 1 squared, then plus 2 integral of dx all over x plus 1 cube. Okay, so if you're going to integrate it individually, so the first one would give us ln x. This one would give us ln of x plus 1. So how about for the third term? So if we let u equals x plus 1, this one becomes, so du is equal to dx. So this becomes the integral of du all over u squared, diba? And you may translate it as u to the -2 du. So same goes for the third one, which becomes integral of u to the -3 du. So this would give us u to the -3 over 3. This one u to the -4 over 4. So so ako na siyang gi-shortcut dapit kay para di kita madugay. Okay, I think what's important is discussing the partial fraction decomposition. So final answer would be negative ln x plus 2 ln x plus 1, then minus, so negative 3 na siya, negative, negative, so this would give us positive. So positive 1/3 of x plus 1 to the -3. Then this one is now minus 1/4 x plus 1 to the -4 plus c. So that would be the final answer. All right, so far okay ra? Do you have questions? Okay, so no question. So for number 3 and number 4, so I don't know if I'm still going to discuss this one. Okay, I think what will come out in the exam is only one partial fraction problem. So let me check if it's correct pa kung I remember. Most likely you're going to have, so for advanced techniques of integration, you're going to have um, 8 problems. So 2 easy problems for advanced techniques, 4 average problems for advanced techniques, and um, 2 difficult ones. So ako pasabot sa advanced techniques is katong 4 kabuk: advanced substitution, trigonometric substitution, integration by parts, and integration by partial fractions. So that will be composed of 8 problems in your midterm exam. So for your other functions, katong mga basic functions, basic integral equations, so you're only going to have 7. So 3 easy, 3 average, 1 difficult, and again that would be for the basic integrals, katong inverse trigo function, hyperbolic, exponential, trigonometric, and katong basic integrals. So you're going to have only 15 items in the exam. So 7 for the basic integrals, 8 for the advanced integrals. Okay? So try to answer na lang siguro number 3 and number 4, but I doubt that it will likely to appear in the exam, the quadratic portion. So okay, Mark, it's difficult to jugayo if it's conjugate. So just try to kuan lang. Try to answer number 3, and for number 4, murag it's an overkill dyan number 4. Kana overkill kaya number 4 basin niya kurata na mo maayo sa number 4. Alright? So I just discussed the first 2 methods. So probably if you want to try to expand this one, um, may mo siyang kuan x squared. I'll just write the kuan lang, the partial derivatives lang. Partial fractions sa inyong kuan. So kanigay siya kay kuan pag siya. Um, linear plus quadratic. So if you're going to factor out x, this becomes x squared plus 2x plus 5. And we all know that the other term is quadratic because it cannot be simplified anymore. So 5 and 1 cannot give you 2x in the middle, di ba? Will not give you 2x, but it will give you 6, siguro 6x. Or negative 4, negative 6 siguro, ana. So it would be ax, then you're going to have bx plus c over x squared plus 2x plus 5. So this will be for number 3. So if you want to try to answer it on your own later. And then for number 4, so you're going to have repeated quadratic. So quadratic. Then this one is distinct linear. So that's going to be a over x plus 1, or rather x minus 1, then bx plus c all over x squared plus 4. Then lastly is dx plus e. So imagine that you're going to expand this much by this much in your process of partial fraction. All right. So I think that would be it for this meeting. So again, try to so I'm not going to bombard you with so much information by partial fractions. So katulad siguro, I just want to give some techniques in partial fractions. And then, so just keep posted by tomorrow or by Friday for the guidelines for your midterm exam. So further questions or Sa man, ano pa may questions? Any questions? Bad reactions? Hello?
Wala ra, sir. Pero murag lisod din siya, sir.
Oh, liso-liso jud siya. Oh, liso-liso jud siya kay para kailangan siya og kanang step by step process jud siya. Para madugo siyang algebra jud ang kaning partial fractions. Well, anyway, just hope that the partial fraction topic will come out in the easy or in the average problem. Okay, so it's purely problem solving. So from the 15 items will require you to show your solution. So again, we all know that there are different tools in the internet wherein you can just search for the answer directly for your integrals. But again, I'm going to scrutinize the solutions that you're going to present upon checking. So, kibawa mo kung saan ako pag-check sa inyong solution. So, I can tell whether the steps are being cut out or na shortcut siya. So, again, try to present um, as much as possible. Try to present a complete solution. Because again, I know where will the steps will be cut out or may mo siyang shortcut or or you tend to opt out in your process. All right. So probably if you really want to verify your answer, let's say if you want to search it online during exam, because again I don't have any prerogative or I don't have any access in your computer to tell if you guys are surfing the net, diba, while taking the exam. So probably my suggestion would be if you want to verify, so probably just verify the answer, but try to use the technique that I taught you katong step by step jud. All right?
Sir, what if the complete ang solution, sir, kay nag-skip-skip?
Ano mo skip man sad siya. So probably mo
Ay,
skip
kanay
sig
murag mo skip og step, sir, ba? Kay murag
Shortcut sir, shortcut.
shortcut, sir.
sa may shortcut. Sige, example daw shortcut.
Like, for example, sir, na kanang simplify na siya diretso, sir, ang kwan.
Oh, kana siguro simplify okay siguro na, but for kana siguro mo magically appear ang answer, kana siguro mo kanang
Ay,
shortcut jud. Oh. But for the process of kwan siguro kanang mga
like, substitution, sir, kanang diretso na lang gi-substitute, okay ra na siya, sir.
oh,
Nag-simplify na diretso.
oh, if it's basic stuff, pwede rin siguro like katong ganina nga I presented it in LN kay ani siya nga kuan. So for example, kani siya I can say that it's um easy di ba kaning first two kay kuan man siya. Murag nakaagi naman ko, but for the other two, probably I have to verify this one di ba kay di siya takaingon na it's directly u to the power of negative 3 over negative 3 di ba? Okay, you have to verify this one. Kani siguro okay ra siguro ning first two kay I think it's basic formula na. But for the other two, you have to do some shifting or rearranging sa inyong term to make the answer more kuan believable nga inani siya. Diba? So I think you can just justify that one once you try to solve it on your own. Nga di siya madaog mental math, diba? Mada siguro for other students, but again, I think probably in most cases, kay kana you have to show it on the paper jud. Kana may nana. All right, so any further question? So again, murag
Wala na, sir.
makuha jud siya inyo na dyan ma-gauge ang inyong pag-solve if pwede ba siya ma-shortcut or dili ana. So probably if ma-shortcut siya, so ana, just try to write it ln x ana. Murag na may mga subnotes or footnotes sa inyong processes. Or if you really want to make your solutions more colorful, ana, pwede sad mo magbutang-butang og different inks, colored pens, ana. Okay, so just so I lang makadlok because as my experience from Sir Tamar, so Sir Tamar is a way more easy in giving exams compared with um, Engineer Fornis, which is the our department chair. So so if si Sir Fornis siguro yung teacher, so makulbaan na mo, pero since it's Sir Tamar, so probably the problems will just be easy. Okay, so
Lahi,
ah,
di departmental ang kwan sir. Calc nga exam nga mga kwan.
departmentals.
But
But
lahi-lahi og ay.
dili akong pasabot ba is ang maghimo sa exam is katong EM coordinator. So before ang EM coordinator is si Sir Fornis. So si Sir Fornis before sa iyang time katong siya pang EM coordinator, daghang kay hagbong kay lisod kay ang exam. Kang Sir Tamar is puro man mga sign kang Sir Tamar murag ang iyang easy kay super easy, ang iyang average kay easy, ang iyang difficult kay average. Kang Sir Fornis ang iyang easy
Tama.
is average, ang iyang average is difficult, ang iyang difficult is extremely difficult ana. Okay? So I think that will be it for this meeting, and thank you very much for enduring the sessions that we have made. Sige, questions.
Excuse me, sir. Will there be choices during the exam, sir, or it's pure conjugate? No choices.
Kana, I think I have to verify that one first. Okay, if it's purely solution jud, so kana siya, you have to present your calculation jud. But I think whether it's multiple choice or not, during the multiple choice nga aspect, you still have to show your solution. Okay, again, it's a
Okay, sir.
way
Thank you.
of verifying us that the answer was really solved and not looked upon the internet. So, kana siguro. Okay? So again, thank you all very much for enduring our everyday session to catch up to the topics. Kay masyado marag di ko ganahan nga maalkansi pod mo sa inyong bayad sa school. Okay? So of course, just try to ask me any questions or email me. So katong inyong mga questions nga magbalik-balik na, let's say for example, you want the assignment to be extended. So there are a couple of students that ni-email na ako but I didn't reply to them kay ako nang nabuhat ang pag-extend sa deadlines. Okay? Sige, question?
Sir, to clarify lang, sir, ang exam sa Saturday, sir, is 1 to 4, sir, no?
1:30 to 4. But
1:30 to 4.
probably you'll be asked to be online 30 minutes before the exam to check
Okay, sir, thank you.
the camera setting, the setup, and okay. Sige, sige. So if there's no any further questions, so thank you all very much. And then probably we'll just meet by Wednesday next week. Okay, but at least to give some time off sa exam. So, di sa mag-meet Monday, but we'll meet on Wednesday. Okay? Sige, thank you and goodbye.
Goodbye and
Thank you,
thank you, sir.
sir. Thank you, sir.
Thank you, sir.
Sige.